You like Duracell? Feed me Duracell.
We don't need them in the show today now, do we? I'm sure nobody's watching me pick my nose, right? Forgot that was recording. I've completely lost my headset. Oh! I hung it right here so that I wouldn't lose it. Dun da 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 da. Wait, is the gain all the way down? It's turned all. I've been sitting here for the last 15 minutes screwing with a microphone that don't work because the volume's turned all the way down. This is really disgusting. Ah, shit. Alright, we have working audio today. Is my audio going to work today? You're going to work today. I know you're going to work today. Oh, the things that must go wrong so that I may continue to produce video. Do we still have sound? Hang on, let me wait a minute. Oh, wait just a minute. Do we have sound? And now? We have sound. We have things moving. We have progress bars counting. I've decided to do this here video completely unedited. Hey Jason, everyone here. Today I'm going to be working on an iPhone 6 Plus that was sent here because it will not power on after a screen replacement. So I'm going to grab the phone here. Now I don't know what I'm getting into. I have not looked at this phone yet. This will be my first look at this phone. I am going to switch it over so that you can see this phone here on my table. When you think you've remembered everything. That just scared... I'm turning that down. Let's turn that down. Jeez. Golly. All right, so the first thing I'm going to do, I'm not going to hook power to this phone. I'm not going to do anything to this phone other than take it apart, because chances are if they sent it here from South Antarctica, there's a pretty good chance that this thing was not able to power on no matter what they did. So let's go ahead and see what we're up against. I would like to say, before I finish taking the screws out, that I firmly believe that this is going to be an issue with long screw damage. Only one pentalobe screw in the bottom, so that is a damn good sign. And if it's not a good sign, then it's at least less work that I have to do. Dun, 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 dun. Please don't be long screw damage. At least don't be horrible long screw damage. We can deal with a moderate, a medium amount. Oh my God. Okay, brief pause. Holy shit. We can deal with a medium amount of long screw damage, but the amount of effort that I just had to put into removing this one battery screw, oh my God. Oh, something tells me that this might be long screw damage, and because of the torque that was on that screw down there, if we have anything similar as far as torque goes on the screw up top, we're in deep shit. All right, here we go. Does anybody want to play a trumpet or whatever instrument that would be that you would play whenever things really bad are getting ready to happen? All right, we've got... Ah, shit. Okay, so the first screw I pulled out that should have been a semi-long one, it's not a long one, it's a short one, so... Oh, damn. Okay. And also, one day I'll get around to rotating this image the way that it's supposed to be so that things aren't like reversed for you. I realize there's been a couple of people tell me that this is just it's like, dude, everything's upside down. All right, well, that's a short screw. Okay, so we've removed short screw, short screw, short screw. All right, let's go ahead and remove this one, which is a long screw, or it wouldn't be tightened down. Who wants to place bets that the screw that is supposed to be right here, who wants to place bet that that is behind door number 5? The last screw that I'm going to take out. And it's really not that bad. That screw's not that bad. So we're going to go ahead, we're going to pull the battery terminal thingy off the bottom here. And we'll pull the top shield thingy here off the top. For those of you that give me grief about using a metal screwdriver, take that. Let's see what we're up against. We're going to assume that this thing don't power on, or if it would not have been sent here from South Antarctica. And let's have a look and see what it looks like under the microscope. Oh God, where's the phone? It's locked up. My microscope's locked up. During the next few moments of this video, I actually forgot to press record on the copy of Open Broadcaster that I used to record my microscope, hands, as well as screen capture. So rather than throw this entire video into the trash bin, I decided to add a little bit of a voice note in here, struggle through the editing process, and make this as seamless as possible, and try to salvage what I can. Let's have a look at these screw holes. Now, I have not had a look at this one yet under the microscope. I started to look at it, and as soon as I did, microscope locked up. Course, record a video, everything fails. So let's have a look and see what we are up against. I'm going to zoom in, focus on the first screw hole. It looks thoroughly pounded. We probably don't have any cuts here. Now these are this is 1V8 SDRAM. If it is shorted or anything, bad shit is going to happen. If this line here is shorted or anything, bad shit is going to happen. This is an I2C0 line. If this line is shorted, this phone will not boot. Okay, so then we've got this line here. This is one of the backlight lines. So if this line is shorted or something, if it's compromised, I'm not sure what will happen if it's shorted, but I know if it's not present, you have a phone that has no backlight. And this here's going to be front camera. If this one's broken, we're not going to have front camera. If this one over here is broken, other bad shit's going to happen. I don't think the phone will boot without this line if it's shorted. And then here is, let's see, if that was our, was it both backlight line? Okay, that's our backlight line. And then here's our chestnut enable. So if chestnut enable here is not present, then you're going to wind up with a phone that just has no image and no backlight. So we know this thing won't turn on after a screen replacement, but people, they get that wrong a lot. Won't turn on could be no backlight, it could be no image. A lot of people are really smart, and they'll know that it's not making any sounds or no bells or whistles and nothing's happening. So won't turn on could mean a lot of things, but this guy's probably right. Let's check our symptoms. I'm going to use something here that I can use to hook this thing to the bench supply. We're going to set our voltage to, lower 4 volts. I'm going to take a iPhone 6 Plus test screen and hook it up to this dude. Just in case something does happen, I'll at least be able to see it. So we're going to pay close attention to current draw before and after button press. If you get current draw before button press, you most likely have an issue on VCC main or on VBAT. And troubleshoot. That it can be a lot of things. So before button press, I just connected. We get 0 amps, which is good. I'm going to go ahead and push the power button, and we're going to see what our load is. Let me explain, before I push the power button, I'm going to explain a little bit what we could run into. If chestnut enable has been compromised, then we're going to wind up with a phone that's going to boot, but with no image on the screen. If the backlight line has been compromised, we're going to get a phone that's got an image but no backlight. If one of the I2C lines here has been compromised, we're not going to get boot at all. If it's been shorted, I know we won't get boot at all. And depending on where it's at on the net, it may not boot if it's been cut. I'm not completely sure. But we know kind of a general set of symptoms that we're after. So here's the button press in 1, 2, 10. And we get bump, 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 bump. See what we get here? I've let off the button press. This power supply is getting 80 milliamps 0, 80 0, 80 0, 80, 90, just, okay. It's trying to make me look like a dumbass by 10 milliamps. So we're at 90 milliamps and blip, 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 blip. That's consistent with more of a data line issue. So at this point in time, I am convinced that we have a problem inside of the screw hole, and it's okay to go ahead and remove the hole and go in for surgery, because that is most likely where this injury is. What really sucks on the iPhone 6 Plus is that I know that this was in for a screen replacement. Now, hopefully it was in for a screen replacement where it was actually like smashed and broken, But with the 6 Plus, a lot of times they go in for screen replacements because of touch IC failure. And I have done lengthy long screw damage repairs on iPhone 6 Pluses, got everything working beautifully, and then wound up being stuck with having to pull the Mason IC off the bottom of the board. Well, I've done my long screw repair with leaded solder. The Mason IC is lead-free solder, and in order for me to get that IC off the board, I have to inadvertently melt my leaded solder on the other side of the board where the long screw damage repair is, and that sucks. It sucks so bad. Now, if you can do your long screw damage repair in a way that there is no tension on the wires other than the surface tension of the solder itself, it's fine. Float it. It'll pull the wires will literally pull themselves into place and connect. But chances are, if it's a gnarly long screw damage repair, you got wires going all over the place, and it's not going to survive being floated. Shit's going to tension, it's going to let go. It's fucking nasty. So let's move on with this repair. The next thing we're going to do is remove the PCB, because if I try to do this and save myself from removing the PCB, chances are I'm going to waste a bunch of time trying to save time and then have to remove the PCB anyways. All right, so we've got the screw hole off of this board, or the let's see, we've got the board out of the phone. Anybody want to place any bets as to what's screwed up? I'm going to bet it's I2C0. Let's remove the screw hole. For now, we're going to be trying to leave the CPU shield. Hey, you got to have fun while doing this shit, man. Sometimes you run into stuff that is such a drag. You got to have fun. Like, you got to. I don't care how bad it sucks. You have to be able to laugh about it, because if you don't, some days you will just make yourself miserable. So we're going to grab a hold of the screw hole, and I'm going to use the wrong tip here, and I'm going to touch it right here with some leaded solder, and we should be able to see the heat travel around it as we lift it nicely off the board. Alright, so right away I'm checking to see if we've got any humped up areas here. See, when it comes to severe long screw damage and it gets to where large parts of the PCB are pulled apart, we've got a little bit going on over here. See the liquid right up here? I'll do my best to focus this, but you see we've got this little liquid squeezy up here. So we've got some detachment up there. I am going to start excavating. And I usually get a new blade. I might stop and get a new blade. Ohm's law. There's our little biscuit coming off. I hope I'm actually recording this. I'm not. I'm not recording anything. Son of a... Alright. Now that I've clicked start recording on my microscope, this video is going to get like 2,000 thumbs down. It's going to be awful. Alright, so I've removed a screw hole. I've been demonstrating. You remember I was sitting here going, you see that? You see? Well, no, you didn't see it because I didn't even have the damn camera on. Up here at the top, this screw hole is slightly pulled apart. Alright, well I might be able to use this anyways. Can't even believe. I missed my first cuts. Terrible. An upbeat video with the recorder off. Now, I'm not trying to go overboard here and get like way out. I know this board is a little soggy up here. Now, I don't know how ripped up it is. I don't know just how bad that is. So we're gonna take baby steps at this one. I would really like to send this out the door, repaired in exchange for money. I've had a couple of people get really, really offended with me about saying, I'm sorry, I can't fix it. Now, in a lot of cases, I'm saying I can't fix it because I really cannot fix it. Some cases I'm saying I can't fix it because it is just, dude, it is absolutely not worth it. And I'm looking out for the best of the customer in a sense that if I did fix it, how long is it going to last? Like, is it going to have other problems? You know, there's a lot of things that come into play when deciding whether or not you're going to repair something. Okay, at this point, I'm going to stop and I'm going to switch blades. I like to use number 11 X-Acto blades because it's the smallest blades that I can find around here, and I buy them at the local Walmart. I might still post this video even though I missed pretty much the whole screw hole excavation deal. And then directly after that, the whole thing that I recorded was blurry. But as far as what's happening here with the data lines being compromised and this phone going 90, 90, 90, 90, 90, blip, 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 blip after you push the power button, that might be useful. So I might still post this even though I look like a total chode. Alright, so we're going to zoom in here. I've got a fresh blade on here, and we're going to start looking for traces. And right now I'm primarily focused at the penetration point of the screw hole. Now, because we need to know what we're after, I'm going to kind of clear this back a bit. Alright, now I'm not sure if you can see this or not, but we can see that we have the shape of the screw right here. Right here we have the shape of a screw. It seems to have cut in right around the side that's toward the battery, like I had suspected. See, I wasn't just completely out of my mind examining that. Although you won't be able to see that because I didn't have the camera recording. Let's put some alcohol on this and see what things look like. At this point we can see our compromise. Let me try to focus this a little better. So it's got this ring. You can see the ring cut all the way around it. And I think that one is going to be our brake, the one that I was just poking at. Let's get some more alcohol on it. Yeah, see what's happened here is that we've got this trace here that normally connects here. This trace right here, the one that I'm clearing back, is broken and shorted to ground, I believe. Let's see which line that is that's compromised. I'm going to move this off the table so that I can move it around. I'm going to spin it around and get the orientation consistent with what's on my screen, and we're going to try to identify that trace. It is the one that turns and goes all gnarly, right? Oh, I'm clicking on the wrong. Let's see, so we've got this lined up right. We've only got one that comes up and makes a sharp turn this way, and then we've got our backlight line here. We can see that backlight line coming up right here, down here at the bottom right corner, right here. And then the one that turns and comes up and makes a sharp turn is right there. So we've got that line identified. If we look at that on ZXW tool, that line is the I2C0 line. So what we have here, this is an iPhone 6 Plus. It has the I2C0 line. It's actually cut, and it's also shorted to ground. So in order for me to repair this, because that line is shorted to ground, it's going to need the short cleared, and then because it's broken, it's going to need a jumper put across it. Now, I think if we just clear the short, it would probably go ahead and boot, but that I2C0 line, that's on its way somewhere. If it's not hooked up, bad shit's going to happen, and this customer is not going to want to pay me for the repair. So in order to fix this properly, I'm going to have to restore that connection. Let's go ahead and switch you back under the microscope, and let's zoom in nice and close. Get some more alcohol on this. I suppose once again I could have checked that line for a short to ground, but I mean you can pretty well see that the damn thing is, it's wadded up into the ground plane right there, so I think it's pretty safe to say, or maybe not ground plane, but don't look good. Alright, so we will get in here. Boy, that is a deep cut. It goes all the way around. Okay, we want this to be cut back just a fuzz. Because I don't trust this little part that's flingling around. There we go. It's going to be like the worst repair video ever. So I think we've got that fairly well cleaned up. We're going to put some flux on the situation, huh? There we are. And I'm going to tin up this shit with some leaded solder. Yeah, so for any of you that have gotten a no-fix notification from me due to long screw damage, this is the sort of shit that I'm willing to do. Like, I'm willing to cut into this board and reattach wires inside of this thing, but once it gets to be so bad, it's not worth it. It's not worth it. It's not worth it for you. It's not worth it for me. It winds up being a data recovery mission. Like, no questions asked. Alright, so now we've got some leaded solder on this thing. I'm going to take some ear speaker wire. Apparently the rest of... no way. It must have broke off. There's no way in hell that's the rest of my ear speaker wire. So let's start getting this down in here. And just remember how small this is. This is probably the smallest thing that I've ever had to work on ever. And just as I remember that I'm doing this on video to show people, my nerves start to act up. So that plays a major part in this. Okay. So we've got the first side, I believe, tacked down, but I can't really see it. We're going to bend this wire a little bit. Okay, it was not tacked down, but we're okay because we still want it to bend. Okay. Now we're going to trim off our access. There we are. Now, since I probably did a really piss poor job at photographing that being done, we're going to go ahead and clean this up with alcohol so that I can show you what it looks like. This is a very simple, straightforward long screw repair. This should not be a rabbit hole that keeps me scratching my head and hooking up so many wires. And you know, what if it's the next layer down you got to break, or what if you've done all this and it's actually a different problem, even though all your traces are fine? And screw that. Once your long screw damage gets to be too bad, I pull the plug for you, and I pull the plug for me. Now, this is only one trace. I mean, just imagine how Frankenstein this shit could get. Alright, so we know that I was worried we had a short to ground right here. And remember, this is I2C0. So let's try to get in. Let's try to inspect my top joint. Looks pretty solid. Okay, so there is the outer solder joint toward the power button, and then that's the inner solder joint toward the battery, but I just don't have enough light to show that clearly. Okay, so this should be what is a really basic long screw damage repair. And as always, my tech power meter has dead batteries. Here is our tech power meter. If you're going to have one of these tech power meters, you're going to want a steady supply of Duracell. First order of business is pull on it the wrong way as hard as you can until you fail, and then grab the proper tool. The next thing you do, rather than pull out a working voltmeter and see if the battery is charged, you stick it to your tongue. That's a good one. So I'm going to check and make sure our I2C0 line here is not shorted to ground. I'm going to put my black probe on ground. And I'm going to put my red probe on the tiny little trace. And we get 12,000 ohms, which I believe is what we would get maybe through a resistor or something to ground. So 12,000 ohms is completely and totally, utterly acceptable. Now we're going to take this PCB and put it back in, let's see, let's go ahead and use my housing. Yeah, anytime one of your I2C0 lines is shorted, bad shit can happen. And in this case, what I did, I reconnected AP BI I2C0 underscore SDA. That don't want to seem to plug in right. All right, let's just skip that one. Let's hook up our power button. And we're going to plug in a screen. And remember before we got 90 milliamps, blip, 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 blip. This time we get... Okay, now as always, we're going to pay attention to current draw before button press. So we're going to hook power up to the battery rail. We get 4 volts. I mean, 0 amps, we're at 4 volts. And then we are going to push the power button. And before we got 80 or 90 milliamps, blip, 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 blip. This time we get, drum roll please, power button in 3, 2, 1. We get 90 milliamp draw. We get 100 milliamps. We get 200 milliamps. We get 300 milliamps. We get, you son of a... half an amp. The phone is booting, but I don't see anything on the screen. I got a dim Apple logo. Okay, so this iPhone 6 Plus is now booting, but with no backlight. And it's not half backlight. It's absolutely, positively no backlight, which means that we need to address one of these other signals. Stupid ass freaking long screw damage. No backlight. So back to the microscope, and let's just have a look down in the hole. Wait, you can actually see it severed. Yeah. Okay, for that, I'm actually going to bridge that with a blob of solder. Like, you can hardly ever get away with this. But if you look really, really, really close right here, right there, there's a break in this line. It's actually cut right there, and that's right where the screw went around. And the screw actually cut up here. It really just screwed all kinds of shit up. So we do have a break right there, and if we look at our ZXW tool and we look at this line, that is that backlight DWI line. So our backlight driving while intoxicated line is also severed. We've reconnected the I2C line that was preventing this phone from booting. Well, we have cleared the short on the I2C line that was preventing this phone from booting, and the phone now boots, but it boots with no backlight. So our next step here is to reconnect this backlight driving while intoxicated line, which should restore backlight. Now it's such a small break, I'm going to attempt to just tin it over. Let's get a lot more flux on it. Should probably use a little less solder on my tip. Okay, we're going to stick a wire there. How come every time I record a video, I lose my spool of wire? Got to be pretty close, right? Chip Quick SMD 291 is probably the worst flux you could possibly use for this, yet I'm still going to use it. You can most likely not see what I'm doing because the magnification is just too much. But after I get it done, I'll show you. I'll tell you what I'm doing is I'm making a complete fucking mess. That's what I'm doing. Okay. Well, let's see what it looks like. I think it's going to look like shit. Look like shit, maybe. Functional and not going to break. Also, maybe. Okay, so my jumper looks like complete total trash, but it should be functional. And now we're going to put this thing back into a housing. Gosh, how fucking embarrassing is this? It's not embarrassing at all. And you can't fix everything. People want you to be able to fix everything, but you just can't. And okay, now we're going to do the same thing. I'm going to hook 4.1 volts up to the battery rail, paying attention to current draw now, and we get 0 amps. We're going to push the power button. Drum roll, please. In 3, 2, 1. Power button. 100 milliamps. 70 milliamps. Yay! Look at this. We get backlight, but we've only got half backlight. And we have right side half backlight, which means this is most likely an issue with the right side half backlight driver. Which is why whenever it comes to repairs like this, they typically are better off, especially on the iPhone 6 Plus, you are typically much better off just to not screw with it. Because now, in order for me to fix the right side backlight, this is most likely going to be the right side backlight driver is not, you know, it's the same exact thing that causes touch IC failure. This thing is going to need the right side backlight driver refloated, reballed, or replaced. And should I demonstrate that, or should I just call it into this? Because I've restored power, I've restored backlight, but we've got wonky problems. And the reason why I say call, for somebody that doesn't know any better, that you'd be looking at this going, well, why the fuck don't he just fix it? Well, after I get done with the right side backlight driver, it's going to have touch IC failure. And then after I get done with touch IC failure, I'm going to have to readdress the couple of little jumpers that I just put in place to get this thing to power up and then to restore data line connection to the backlight drivers. So what do? Do you call it? I tell you what, just for the sake of this video, I'm going to go ahead and pull the shield off of this, and I'm going to show you what I mean. And we're going to let gravity do the work here. Now, if this is heavily underfilled, I'm going to stop. I'm trying not to float my micro jumper job over there, so I'm keeping my hot air away from that. Yeah, if this backlight driver is heavily underfilled, I'm not going to touch it. Okay, so now we've got that off of there. We're going to swoop right in with the microscope, and we're going to have a look at the right side backlight driver, because I do suspect that that is where our fault is. I don't think I have enough tension on the jumpers down here for things to get all wonky, so I'm going to add a little bit of flux. There. And I'm going to carefully refloat the right side backlight driver with hot air. I'm currently out of stock on those, otherwise I would just go ahead and replace it. At this point, I feel like this one's going to wind up leaving here as a no fix, not because I can't fix it, but because I don't want to warranty it. Once these things start to have wonky things going wrong with them due to being bent, which I strongly suspect is the case on this, the iPhone 6 Plus develops some really nasty issues. You can go through a lot of headaches only to wind up with something that won't get cellular service when you're done. Alright, so we're going to start gradually heating the PCB. And I'm going to trust that my long screw damage jumpers over here stay intact. We're going to get this IC to the point where it'll float, and I'm going to give it a little nudge. Okay. This one could be more of a typical traditional fried backlight. I didn't even check for it because it's so damn common. Alright, so we have done nothing but jiggled the IC a little bit. That was the right side backlight driver. Now I'm going to put this thing back into a housing, and my goal here is to have this thing now start up with full backlight. Realizing I forgot to re-inspect my long screw damage repair. There we go. Now, this time around, I know that the board was booting before, so it should still hopefully be booting now. Instead of using the power supply, I'm just going to stick a battery in it, because we're wanting to see if we've got full backlight, because I wanted to show you that it is in fact the right side backlight driver and not long screw damage. because it's a fucking iPhone 6 Plus. Make a liar out of me, you son of a... Alright, we're going to move on. Guys, that is going to be it for this video. From here, this phone, I might go ahead and put a right side backlight driver on it. I'd be willing to bet, let's go ahead and let it boot. I'd be willing to bet we do have visible touch IC failure. If not on this screen, then on a different screen. Let's let it come all the way up, and I'm going to check it for touch failure. Could actually be a blown filter. I now have a lock screen. Let's see if it'll drop touch. Yes, no problem dropping touch. Alright, I don't know if you'll be able to see this or not. I'm going to try really hard. If we drag over... Alright, see we have no touch. We're going to turn it off. Turn it back on. We drag halfway over. I'm going to lightly touch the board. Now it's going to make it... Oh, nope, it dropped it. And we have no touch. There's touch. Drop touch. I don't know if you can see that or not, but when I give the board a little... No touch. Give the board a little bit of tension, it drops touch. So... This is why whenever it comes to the iPhone 6 Plus, whenever they come in long screw damaged, can I sit here and run these wires with my shaky nerves? Yeah, I can. And whenever I'm not doing a video on it, I can do a pretty damn nice job too. But this is bullshit. You wind up getting into this situation where, okay, it's long screw damage. Why did it get long screw damaged? Well, the screen was broken. Or it had touch failure. I think in this case it was actually dropped and broken, which if the owner didn't know they had touch IC failure, that drop and break is what triggered it. So here you go. This thing came in long screw damaged. You make the decision of whether or not you're going to fix it, because there's a pretty good chance on a 6 Plus, after you fix the long screw damage, you're going to wind up dealing with touch IC failure. So if it's long screw damage, you might as well just go ahead and do touch IC failure first, because it sucks to do it after the long screw damage repair. And then you wind up with issues like half backlight and just all this other stuff. Let's say you got all the time in the world and you decide to fix a double pound and long screw damage on an iPhone 6 Plus. Yay, you got image, but now you have half backlight. So you go ahead and replace or reball the right side backlight driver, and it's like, yay, now the phone boots and you have full backlight, but the touch is wonky or you got flickering gray bars. So then... Sure, you can fix that. You can, Jason, you can fix touch IC failure, right? You're not going to whine about touch IC failure. You're not going to whine about the repair that caused you to be blasted out into the world by iFixit, right? Yes, I am. Because on the iPhone 6 Plus, here you've went through long screw damage. You've went through right side half backlight. Here you have had to reball the Mason IC, and you have put the M1 jumper in place. And God help me, everything is going to be perfectly fine now, right? No. Searching, no service. The iPhone 6 Plus, whenever they have injuries like this, there's a lot of times when I will say data recovery only, because I'm avoiding a long, drawn-out, nasty chain of events that just completely, totally waste your time. So, guys, that is going to be the end of this video. I don't think I'm going to completely seal my long screw incision on this one. This is most likely going to turn out to be a no fix. Since I'm dug in this far, I might go ahead and poke around and see how much farther I can push it, but... I'm in it to make money. You know, I've got a big heart and I want to fix everything for everybody, but I also got to feed my family. And so I hope you have successful repairs. I thank you for your likes, your comments, subscribes, and I do apologize that most of this video really turned out like shit. So I'll see you next time, everybody. Have a good day.